Anyhow, as I was saying, we're going to have a lot of properties that you need to know and remember. You have taken a look at one way, shape, or form. You have seen these properties of exponents before. Make sure that you have them written down. I realize that that they can be a little on the tricky side. We don't use them very often, but you need to make sure that you have them written down for reference. Okay. Likewise, there was two other things that were in here. No, there were not. So just go over these and reiterate these. Do some simplification. Now we always want to make sure that we understand that the denominator is not going to be 0, because if we have denominator being 0, we end up having division by 0, and division by 0 is, wasn't very forceful. Division by 0 is undefined. Yes, not 0. Nope. Nope, 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 not 0. Undefined. Okay? Because you cannot end up putting in, how do I want to put this? Well, it's a multiplication that could not have happened. We've talked about that before, and I can double check. Let me do it this way. Do you guys know that 6 divided by 2 is equal to 3? Sure? So that means that 2 times 3 is equal to 6, yes? So what happens if I had 6 divided by 0? What's it equal to? Well, that means that there has to be 0 times some number equal to 6. Is that ever possible? No. This is why we say division by 0 is undefined, because we cannot define the multiplication that creates the values. So, now, you understand that multiplication is repeated addition, yes? Powers are repeated multiplications. So if I have 5 to the 6th power, that really means that I have 1, 2, 3, 4, 5, 6 up there, and 1, 2, 3, 4 down here. So 5 squared. So if there's 4 down here, 6 up here, this is just simply going to be 5 squared. Okay. Likewise, if I look at what B is, that means this would end up being 1 over y to the 3rd. 2 up there, 5 down there, cancel it out. Now, a lot of times they're going to want the answer in one of two ways, either a positive exponent or all variables or all things in the numerator. That means that this could go up as y to the negative 3. Let's see, which one of those little rules is that one, right? That comes off in the quotient property. This gets moved up, negative. Okay? Or if you want more specifically down here, a to the negative m means 1 over. I will tell you this much, what you might want to make sure that you write into that is that you have, put that 1 over a to the negative m is going to be equal to a to the m. That's an addition that you might want to make sure that you have in there. It's just an extension of it. Makes sense to have, but a lot of times people don't look like, oh, I can do that. So you can think of this as being over 1, and that ends up being over 1. So just a point to keep in mind. So that's how that one would go. Now, if I were to take a look at, say, C would end up being something like this. each one of these has got to get multiplied by 3. I got 3 of them, right? So really that means 3 cubed, x cubed, y cubed. Now, whenever you have a value to a power, simplify it. So that means this really should be 27, x cubed, y cubed. Likewise, this here should have been 5 squared, which was 25. Should remember to do that. What about over here? Same thing. Y is going to be to the 4th. Z is going to be to the 4th. That's it. No more, no less. Now, over here, they have something that looks fairly ugly, right? This is multiplication. When we have multiplication going on here, we simply go through and add the exponents. So we want to make sure that we take care of that. So we're just going to go back into here, add these exponents together. So that means it's going to be 3 to the 15 minus 2m plus 2m. Yes? So those two wipe out. We really have 3 to the 15th power. Now, I had said that if you got a number to a power, you can write that. You should go and figure that out. Problem is, if I go and take a look at that, I've got 3 to the 15th power. Okay, that one turned out to be a fairly easy number to deal with. But a lot of times you'll get something that'll end up being in scientific notation. So be aware of it. Let's see what else touch on. Oh, don't those look like fun? Oh, these are so much fun. You guys really are concerned about what I call fun, aren't you? Now, one of the things that we have to keep in mind is if we have the same bases, just add the exponents together. So if I look at this here, I have a -2 and I have a 5. I don't have any powers or anything else to it, so -10 would make sense, correct? So I got x to the -2. I have x to the -2 here. So nothing else going on here. So that's going to be x to the -4. I just simply add the exponents together. What about for the y? Well, that y just got a 1 there. That's a -3. So that would be y to the -2. We just add the exponents together. Now, they want us to write the answer with positive exponents. So I am telling you this now. In the assignment, if it says write them with positive exponents and you don't, it's wrong. Read the instructions, follow the instructions, do the instructions. Okay? So now I've got to fix this. Well, the -10 is going to stay up on top because it doesn't have a negative exponent. These are going to go down into the bottom. So if they get moved from the numerator to the denominator, they are now x to the 4th. They are now y squared. That's it. I've said this a long time ago that when we're dealing with algebra, we like to keep things in the form of a fraction. Think of a numerator, think of a denominator. This makes life easier when we have to simplify these kinds of things. So let's take a look at B. Okay, what's going to happen there? Well, 8 and 2, that would just cancel out, so that would go to 1, that would go to 4. Yes? Isn't that what would happen there? So I got 4. I have an x here and I have an x4 down here, so that means in the denominator I would only have 3 of those left because one of these x's here would cancel with one of them down here, and that's where you're at. So what about the y's? Okay, I got -2 of them up here and I've got -6 up here. Well, the nice thing is as long as the signs are the same, you can cancel them out. But a lot of times I don't like looking at it that way with negative exponents. Change them to positive. So that means this could go up here as y to the 6th. Yes? This could go down here as y squared. Is it easier to see what's going on with them now? So 2 of these wipe out with 2 of these, and I've got 4, and we've got y to the 4th. It is a lot easier dealing with positive exponents than it is with the negative exponents. So if you want to, change them out, switch them around. You know what the rule is. There is nothing left to cancel, so we are done. Now the next one just looks flat out ugly, doesn't it? It's a fraction over a fraction, which is itself a fraction. Okay. What operation does fraction imply? Division. So can we divide by fractions? No, but we can multiply by their what? Reciprocal. So for this one here, I would write this out as 2x to the negative 1y over 3a multiplied by the reciprocal, 5a over 6x y to the negative 2. Now we can go cancel happy. Okay. Cancel what we can. Let's see, I've got an a down here that would cancel with an a up here. This 2 would go to 1, this 6 would go to 3. I've got x to the negative 1, I've got an x. So I am going to take this x here and move it down here as x to the first power, correct? I have a 5 here, nothing I can do with that. And I got y to the negative 2, so I'm going to take this and move it up here as y squared. So that disappeared, went down there, that disappeared, went up there. Now, you guys are always looking for shortcut ways of doing things. That's it. So this results in numerator. That's 1. I have a y here and a y cubed after I get done with that. So why in the world do I have 2 y's there? So I have y cubed and a 5. Down below, I have an x and a 3 and a 3 and an x. So that looks like 9x squared. That makes sense? It's a lot of things going on at one time, but you have to make sure that you can see what all the bits and pieces are. You are going to be having rather complex fractions like this. Take your time, write them all out. If you want, write one thing out at a time. Don't try and jumble it all up unless you understand it. Now, the next one. We have got this to some power. I got 4 to the 0 power x cubed and y to the negative 2. By the way, what is anything? And there is a certain caveat to that, but we're not going to talk about it right now. Anything to the 0 power is what? Is it 1? I don't know. Is it 1? Anything to the 0 power is 1. I don't believe I see that sitting here on any of those. Talk about that. Should have been in there. I don't see it listed in here. So another thing that you should make sure that you have down that goes with this then is going to be if I have a to the 0 power equal to 1. Now, why is that? Well, here's the why it is. If I have a to the 0 power, that could be, say, a to the first power over a to the first power, right? Because that's what equal what's equal to 1. But if I bring this up here, that would be a to the negative 1, right? So that means that I would have a to the 1 minus 1, which is equal to a to the 0. That is why a is equal to 1. Anything to the 0 power we say is equal to 1. Of course, 0 to the 0 power wouldn't be equal to 1 because that's just a whole other thing. Okay, because that would imply 0 was in the denominator, which is undefined, which you can't do. So let's go back here. If I see this here now as 4 to the 0 power, that's just what? Well, that's really just 1. And what's 1 times anything? Anything. So really what this is going to be is this negative 3 goes here. So that is going to be x to the negative 9. This goes over here, and that's going to be y to the 6th. However, they want it with positive exponents, so it would be y to the 6 over x to the 9. Mental gymnastics with exponents. Some stuff. So let's take a look at these wonderful things. That's not what I wanted to do. Now, you are also going to run across things that look like this. Okay. Fractional exponents. Fractional exponents follow the same rules as regular old integer exponents. Fractional exponents follow all the rules of fractions when you're adding and you're multiplying. So if I am looking here at a, this is going to be x to the what power? Now, one of the things that I dislike about writing fractions like this, and I caution students against it at all times, when I look at this, it does not really give you the idea of a numerator and a denominator. They cancel out, so I end up with 1 over 4. It doesn't lead you to that idea that you can actually cancel there, does it? When you're looking at them in line like this. I realize why they do it, and it's easier to type it out. I recommend that you, when you're working on your assignments, write out the fraction as a fraction is supposed to look. It'll be easier on your mind. So if I take a look at this one, I've got y to the 1/2 divided by y to the 2/5. Okay. Now, this can go up here as y to the negative 2/5, correct? The 2's cancel out. Denominator down here, numerator up here. So I would have y to the negative 1/5, which really means that I should have it as 1 over y to the 1. Does that puzzle you? Some of you are looking at it rather harshly. Just follow the rules of exponents. So, interesting. What about the next one? What is the rule of a power to a power? What do I do with the exponents? What is the rule for a power to a power? Multiply. Oh, hold a sec. Didn't I just do that for A and B? So did I do those right? Why didn't somebody say something for those that are nodding your head in agreement now? Don't just look at it and nod your head and go along with it. guys have been doing that too much lately. You have to be thinking critically about all of this. So that means that everything I wrote down is wrong, and everything that you wrote down that I wrote down is wrong, but you didn't catch it. You've got to take a look at this and see what is going on and understand the rules. When in doubt, go back, take a look, and see what you are supposed to do. Watch this is why you have the rules. Multiplication, you add the exponents. Power, you multiply the exponents. So let's go back and redo that. Now you have to do the thing that you don't want to do. You do not like taking 1/3 and adding 3/4. Okay? You got to get common denominators. Do not use decimals. Do not. So what's the common denominator for 1/3 and 3/4? 12. So I'd have 12 here. I'd have to have 12 here. So 3 times 4 is 12. 3 times 3 is 9. 4 times 3 is 12. 4 times 1 is 4. So 4 twelfths plus 9 twelfths is going to be what? 13 twelfths. Okay. Depending upon what you want, you could leave it like this. Let me check back and see just what they did. If they left it as such. I think they did. Didn't they? Yep, left it as 13 twelfths. So far, so good, right? Over here, division, subtraction. So that is going to be 1/2 minus 2/5. What's the common denominator for this? 10. 2 times 5 is 10. 2 times 2 is 4. 5 times 2 is 10. 5 times 1 is 5. So 5 minus 4 is 1/10. So I've got y to the 1/10. Never realized fractions were that easy to add and subtract, did you? What about the next one? This is where multiplication comes in. So it's going to be 1/3 multiplied by 3/4. This cancels out and I end up with c to the 1/4. Part of the reason why I want you to be able to take a look at it is when somebody else in the class asks you, you're working together on this stuff and you want to know, what answer did you get? What did you get? You have to be able to take a look at what you're working on and see where it's going. Okay. So, scientific notation, just be aware of it, what you get. The calculator does things a little strange. They always get that E back there. Basically, that just means that whatever this number is, the E is 10 to that power. Okay. So keep those things in mind, and I am going to let you get